Hello guys, welcome to another tutorial about procedural workflow. Here we're going to talk about using Houdini to procedurally create a stair. And we are going to create controls to control the height and width of the stairs and how many stairs we're having, and also the entire width of the stair, and many other smaller details down the way. So in the network, I'm gonna right click or hit tab button and type in a geometry to create an empty geometry. We can name this guy stairs, and then instead of it we can go start with just a point. So we can do just the add node or add 1 point. Okay, you can see now at the origin there is a point 0. You can visualize the points by turning on the point number visualization. In the viewport, you can holding down the button to go to the visualization. Here we can go to the guides and turn off the origin nomen, so that's easier to see that point. Okay, so there. Right, that's going to be our first point. Okay, and then based on the height and width of the stair, we're gonna go create multiple points like this, and then we connect them backwards to create the base profile of the stair. Okay, we can call this guy start point, and then we're gonna go create a attribute wrangle. Okay, attribute wrangle is basically running a script here on those different various components. You can choose to run on every individual primitives or points or vertices, or you can run also once. This is actually what I'm gonna do here. Just run once. Okay. We're gonna call this guy populate points. Okay. All right. So let's click on this visualization bar to display the results of this attribute wrangle. And we're gonna try to start adding points. Before we actually add some points though, we need to know a few informations, like how high each stair is and how deep each stair goes. So I need two variables, float stair height, and we can make that equals to a channel called stair height. And we can do another float and call this guy stair depth, and again equals to another channel, and this time maybe it's called stair depth. Okay, all right. And then you can Control A, Control Enter to run it, and go click on this little button to create those two channels here. Channel is basically attributes. Okay. So now those two variables will hold those two values you specified over here. So we can change it and make adjustments. Okay. Now with that information, then we can start to add a point just to test it. I'm gonna say add point. Okay, when I add a point, one stair height from the center, which is 0, 0, 0. So we can say add a point on geometry 0, which is the first input to this attribute wrangle. You can go up to 4 inputs. And then when I say at the position will be the value, we can say set. And then for the x direction, it's going to be 0. For the y direction, it's going to be the stair height. And then on the z direction, it's going to be 0 and semicolon, Control Enter. You can see how we're adding one more point over here, right? I'm gonna keep on adding points in this kind of like zigzag way or staircase way, right, to go up. So that means we cannot just add points with a lot of lines here. We kind of like need to go through a loop. Okay. All right. I'm gonna start with a vector at the origin here. Vector origin. Or let's just use it as the value we're gonna use and gradually increment over the time. So maybe new point position. Okay, it will be equals to 0, 0, 0 for now. Okay, and then I want to do a for loop to go through to create as much stairs as we want. Okay, so let's go create a stair count variable. That's an int, and then it's going to be from the channel chi as a integer channel, and then it's going to be called stair count. Okay, run this. And maybe we go for like 24 stairs. Okay, then we can say 4int stair equals to 0. Stair is smaller than stair count, and then we increment stair. Okay. Alright. And then we will have to actually go create points differently every time when we have one goes up and then another one goes in, another one goes up, another one goes in. So it's gonna kind of like flip-flopping between going up and going in. So in that case, we can use a boolean to always flip it. Okay. So we can, there's no boolean in this Vex language we're writing down here. So that means that we have to use an integer to just represent boolean. So I'm gonna say b go up will be equals to 1 for the first point. Okay, we can say if b as boolean go up equals 1, or just that, did we do something, right? And then else we do something else. Okay, so if we're going up, of course we're gonna go up, and if else, then we do go inwards. But we have to flip this boolean also. So b go up will be after, if it's true, then we make it false. So equals to 0, and then b go up will be 1 in this case when it's not true in the first time. So we're basically flipping the boolean. Okay. All right. So the first time we wanted to go up. So let's say the new point position here, that's this one, will go increment up. So plus equals to a value that's going upwards 1 stair height. Go and make it longer. Stair height on the y direction, of course, and no z direction in this case. Okay. If not, then the new point position will be incremented differently. We're going to increment it to go deeper or go horizontally stair depth amount, right? So this is going to be in the x-axis, and up is going to be 0, and z direction will also be 0. Okay. All right. When that is done, then we can just add point in the for loop, of course. Add point. The point will be added to the first geometry again, right? This first input, and then we're going to say the position will be the new point position. Okay, so it's going to add a point here at this position on the first input. Okay, let's go ahead and run it. You can see now how we're getting a bunch of points all the way up to 24. Okay, but there's actually a little catch here. We could now use this stair count to tweak like how many stairs we're having. But the problem is there will be cases that you have the stair like this, ends up like this, right? Now that's not ideal because you will always want this one to not end like that. You want to have like one last stair up there, right? So that means the number, if possible, it should always be like a even number instead of an odd number. Okay. And because it just has to be true, then maybe we can just make it true in the first time when we're checking it. So let's say if the stair counts divided by 2, its remainder is equals to 1, then we increment the stair count by 1 to make sure that it's always an even number. Okay. Alright, so now whatever stair count you're adding here will always be eventually becoming an even number, right? So we're gonna go ahead and go to the checker, the setting here for this Rango node. Go edit parameter interface, and we can look for that stair counts channel we added in through the code. We can say you are ranging from 0 to 50, and then accept that. Now we can just drag this. You can see now we're basically able to produce whatever amount of stairs we want to go for, right? Which is pretty cool already, right? But there is a catch here though. We can, if we connect all those points one by one through the point order, it's not going to give us a geometry. It's only going to be a line. We want to create the profile of a stair, so we need one more point down there and one more point down there, right? That's 2 points. So let's add those 2 points. Okay. Add one more point to the first geometry. The position will be the current, the previous point position, which is point 28's position, right? This guy's position will be then minus a stair height on the y direction. So it's gonna be minus that 0 point that point and then 0, right? That's one more point. As you can see now, point 29. And one more point will be 1 unit or 1 stair depth inwards from the first point. So add another point. We'll add to also the first geometry, and this time it's just going to be the value from origin to 1 unit, 1 stair depth on the x direction. So all I have to do is copy the stair depths, and then we're going in, and then nothing else. Okay, one more point. All right, so now we have points created in order. If we connect them all together all the way across, it's going to be a profile. Okay, to do that, we need to use a add node, and then the add node will be using polygon by group. You can see how it's going to go all the way, right? And then we can choose close, so it's going to actually create a polygon for us. Okay, all right. Now after that, we can see now we can use this populate points to like control how many stairs we're having, and the stair depths and the stair height. All right. The reason we wanted to use those two values to drive the stair instead of say how high the entire stair is just purely for the architectural point of view. Every stair has to have that unique size so that it's not too big or too small, so that when people are working on it, if people are working on it, right, they don't get, blocked that easily. All right, so create stair profile. All right, so once that is done, then we need to give it some thickness. So I guess what we can do is create an extrude node, extrude poly extrude. Okay, and we can extrude the faces outwards. It doesn't really create the back face in the default settings. You need to go ahead and say output the back face. All right, and then another translate our transform. We're gonna shift it away from the center on the z direction by some, and then we do a mirror. Okay, and the mirror direction will be to also the z direction in this case. Right, so now the mirror, the transformation will be able to determine like how far away or how wide the stair is. You can hold down the mouse button and drag those values to change the numbers there. Okay, it's getting annoying to see the points. I'm gonna disable that. All right, so we have set up a few things already. I think it's time we can actually set up some controls to control those variables. Okay, so I'm gonna go create a null node and go to the shape and give the null node a circular shape and make it also a red color. I'm gonna call this guy control. Okay, for the control, I'm gonna give it a few parameters. Go to the settings here and go to edit parameter interface. I'm gonna go ahead and create a bunch of variables. First one is gonna be a float. I'm gonna call this guy stair height, right? And then that's the label. That's the actual attribute name. Okay, they can be the same or to be different. This is how it's going to be displayed here in this attribute panel here. Okay, we can define a range. Maybe it's going to be from 0 to 1 and apply. You can see how we're getting this one attribute, stair height, right? And then we can drag in another float. Call this one stair depth. Also ranging from 0 to 1, I guess. Apply that. Okay, and then another integer. And call this guy stair count. And then it can be ranging from 0 to 50. Apply that. Maybe one more float for stair width. Also floats ranging from 0 to 3, I guess. Apply and accept that. And now what we can do is we can just give them some value here for now and just right click and say copy parameter for the stair head and go to the channel here, and we can just paste relative reference. Okay. Right, what this does is basically saying whatever value this one is having is going to be also the value here. It's reading the channel from the control's stair height. Okay. So now, oops, sorry, let's put the display bar there. If I grab the control and drag the stair height, you can see how I'm able to change the stair height now. Okay, we can do the same thing for all the others. So copy parameter from the control and go to the specific place that actually has that parameter. We can then just paste relative reference. Okay, copy parameter and put it in here. And one more parameter for the width. Okay. And then translation. Now here we have to be careful though. If we use this number here now, it's only half of the final width, so we need to divide that by 2. Okay. That way the width here is the actual width. Right? If it's 1, then you're expecting it's 1 unit wide, right? Like this. You can see that's the same length. Okay. Alright, so now we have a whole lot of controls already to control it. But we want to create planks here as the actual stairs, right? For now it's just the frame. Okay, so we can start with maybe a box. Okay, and we can populate the box along the points we have over here. Okay, so I'm going to create a branch from there with an attribute wrangle. Here, turn on the point number here. I want to populate the planks, but not on the last 2 points and not on the first one, because those are not supposed to be having any plank on them. Okay, so I can say, okay, in the details, let's say remove point. Yeah, remove point from the first one. I want to remove the first. So 0, 0, right? That's going to delete that first point. Last 2 point though, it needs to be a little bit different. I need to know how many points we're having. So in point count will be equals to number points and the number points of the first input. Okay, and then we can remove more points now. Remove the first input's last point. But that has to be this number minus 1 because the actual number starts from 0. So that has to be that, and this is minus 2. Okay. Now you can see we're eliminating all the points we don't really need. Okay. Also, to populate the cube, I want to populate that cube on those odd numbers and get rid of the even numbers here, right? So we can create another attribute wrangle to run through every point this time. So this time it's going to be on the point. Before there were like this one and this one, they are on the details here, right? So it's only run once, but here it's only run once, but this one is actually going to run on every individual point. The good thing about this is you can always reference the current point number by saying at ptnum. Okay, so let's say if the at ptnum as point number, its modular result of number 2 will be equals to, let's say, 0. That means it's an even number. I don't want it, so I'm going to do a remove point, and we're removing it. So 0 and then at point number. Okay. Now what happens? You can see it's getting rid of these guys, leaving us just these guys. And that's where we want to actually populate our stairs. So before we do any like changing to the shape of the box, we can try to copy it already. So I'm going to say copy stamp. Okay, box will be the first input, and points will be the second input. It's going to copy the box to the individual points on those on this second input. As you can see, this is what we're getting. If you go ahead and grab the box and make it smaller, you can see what what do they look like. Let me turn off the visibility of the point numbers. We can then merge that eventually with our stairs. Okay, and let's hit space 2, space 1, space 3. Yeah, so go to the set view and hit W to go to the wireframe node. You can see, well, that's not quite right. I want the pivot point of the boxes to be on the lower right corner here, so when they are populated, they're going to be in here, right? So back here to the box, first of all, I don't need uniform scale, okay, but I want their pivot to be over here. And that means it's going to go go to the positive X direction, actually. So we're moving it backwards on an X direction in this case. So I'm going to copy the size X and paste it in the center, but then go divided by 2 here first, and then go negative. Alright. And then for the direction Y, we can also copy parameter and paste it in here. And that's going to divide it by 2 too, because we're only going halfway, right? If I shrink down, oh, we cannot do that actually. But you can see now every individual box is having its lower right corner going there. Meaning that if I'm able to, like, say, change the size of the X and Y and Z, you can see how I could get them work already, right? Space 1 to go back to perspective view. Hit W to go back to the wireframe mode, to the solid rendering mode. Okay, you can see it's really flexible now. I can change those numbers to determine various things about this stair, like the size, the depths, right, of the stairs, the height of the stairs, and also the width of the stairs. But I want it to be a little bit more automatic. I want it to be at least the width and height of this space here. Okay, so to do that, I need to get that value somewhere. Okay, and the value for the width is going to be here. So I'm going to go ahead and copy the stair width, and that's going to be the size for the Z. So paste directed reference. Sometimes you'll still have the number there when you're pasting. Make sure that you just have the channel there. You can see how it's snapped to the size of the stair, right? Which is really cool. Okay. And then we can also determine the depths. We now know the depths already in the controller, stair depths. You can copy that and put it in the box and delete that and just paste the relative reference. Okay, you can see how they extend it to the same depth as that. Okay. The thickness here for these guys can be compensated also for the Z. Okay. In that case, we need to have that control. We can say a new float stair base thickness, maybe. Oops. Make sure that you name your stuff consistently. So that's how I name it here, as the name for the label is going to be stair base thickness. Missing an edge over here. Okay, ranging from 0 to 1, I guess, and then apply, accept, copy that parameter, and we can use that to control how much we're extruding here. Okay, and that can also be used to add extra thickness to the channel. Plus, paste the relative reference. I guess we need to multiply that by 2 because it has 2 sides. Alright, that way it's like all filled in properly. And meaning that no matter how we change those things, like, you know, the entire width, the base thickness, right, the height, it's always going to be fitting into that spot. I think the only thing we want to change here maybe is the height for now, so I'm going to go ahead and do that. One more float. Stair plank thickness, maybe. Stair plank thickness. And then ranging from 0 to 1, I guess. Apply and accept. Copy that parameter. And that's going to be the scale Y. So paste relative reference. Cool. Now we can use that to control the thickness of the planks. Okay. Maybe sometimes you want to extend out a little bit more on the 2 sides. So we could create 2 more attributes. Stair front extension. Okay, maybe also ranging from 0 to 1. Apply, and then we drag in another one. Call this guy stair side extension. Okay, and yeah, stair side extension. It's S, right? Should be S. Okay, ranging from 0 to 1 again, and just apply and accept. So now we can copy the parameters and put it to the box one. Let's say size X will be plusing the extension here, and then the set extension will also be added into the Z scale. But that's the extension on one edge, right? So that means we need to plus or multiply that by 2 also. If it's hard to do, you can Control E, Alt E again to open the editor here, like this, and you can tap 2 and then apply, accept. All right. So now we can go toggle the visibility here, right? Go grab our control. We can extend the stair to the side, extend it to the front also. Can change the thickness. Can change the thickness here too for these guys. Okay. We can do a whole lot of cool variations already, like like this, right? It's a completely different stair now by just tweaking a few parameters. Okay. Yeah, so that's gonna be it for this video. As you can see, we can do a lot of flexible change, like how many stairs we're having, how long they are, how deep they are, right? How wide they are, and the thickness here on the base. Okay, and then we stair width. Yeah, that's the one. The thickness here, so we can make it empty in the middle also. And yeah, I think that's it. So as you can see, then maybe it's gonna take you a while longer to develop things like this. But imagine that you have done something wrong in the modeling. Maybe the height is not proper for the individual stairs. It doesn't work with your character's animation or things like that. Then you have to basically drag a lot of points to make it work, right? But here you just need to change this parameter and you're done, right? Because this is all non-destructive. You can do a whole lot of changes without the effort of redoing things. Okay, and that's the power of procedural modeling. And that's why, you know, a lot of people are trying to adapt to this workflow just for the flexibility and also the ability to be able to make iterations really quickly, and produces a lot of things. Like if you're making like an rock asset and you want to make a whole lot of variations, things like this this kind of setup can give you a whole lot of variations, right, for that particular type of asset, and your productivity will just be multiplied a whole lot. Okay, yeah, so that's it for, you know, some simple example on procedural modeling. I hope that all those things can help you and give you some ideas on how this works from the very foundation. You can see a lot of coding here, of course, but you know, they're simple languages. It's like this C# language, if you're familiar with that. If you're familiar with that, or basically C-style language, it's a fairly easy language to use if you're familiar with any other programming languages. Just need to remember the functions and what they do primarily, and some algorithms you may need to use in the future. Alright, that's it for today. Thanks for watching. See you next time.